All right, so what if we're given our values in a table? Well, we can see here we have some function given to us, some f of x with our x's and their outputs. And then we can look at the resultant function. So for g of x, it appears that all of the actual outputs have stayed the same as our original f of x. But we can see that our x's have changed. So we can look and see what's the change. Well, 2 became 3, 1 became 2, 0 became 1. They've all had 1 added to them. In fact, you can go ahead and make yourself a quick little sketch to see what this looks like, right? So it looks like I need to go -2 to 2, all the way down to -3 and up to 2. Our original graph here, I'll do it in red, f of x, -2, 2, -1, 1, 0 at -3, 1, 1, and 2, 2. So that's my original graph. Heck, if you want to, you can connect to them. There's nothing saying that these dots are connected. So that's always a sketchy thing to do. But if you wanted to do it just to sort of visually see what was happening on this graph, we could kind of make this crazy looking V. And then we can look at our new graph. Our new graph, our g of x, -1 is at -2. 0 is at -1. Then we get our -3, then our 1, then our 2. Boop, 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 boop. So we can see this is +1 has actually taken our entire graph and shifted it to the right. Right? We've shifted it to the right, which makes sense. So how am I going to write g of x? Well, it's f of x, but inside, because we have manipulated our x's, we have taken all these x's and we have subtracted 1 in order to have that shift the other way. So basically, if I plug in a -2 or -1 to this original function, this is f of -1 minus 1, which is f of -2, which will give me out -2. So that's where this is all happening, right? So how do we change our inputs? The second one, our h of x. Now we can see all of these have stayed the same. All of my inputs have stayed the same. But we've changed the outputs, which is much easier, thank goodness. Our outputs went from -2 to 1, 1 to 0. It looks like we've changed all of these by adding 1 to the original, right? So same idea here. This is going to be f of x plus 1. And in this case, plus 1 is on the outside instead of doing the opposite because it's happening to our y. And you can always, of course, graph these to see why this is the case. See that we take our original graph that was red and we've shifted it up 1. So this was a shift up. This was a shift to the right. And then our original. So there we got algebraic and numeric, and we'll move on to graphically.